name is Paul, doing a PEOE with VID00029, and what I'm going to be doing for you, for your observations, is I'm going to be taking an aluminum pop can. I'm adding, I don't have a tablespoon, but a couple tablespoons of water into the bottom of the pop can. And then I'll be putting this on a hot plate, and I'll be heating up the whatever water's in there, okay? And then once I hear it boiling, I'm going to be grabbing it and putting it inside this very full bottle.
Too full?
So it's okay, of water. But I want to see if you guys can make some, it's good, some predictions on this. So, Brigitte?
All right, so what does everyone think would happen to the actual can?
When I dump it upside down into the cooler water.
It'll contract. Yeah.
The can contracts, and why do you think that would contract?
It just contracts.
Just because? Okay, just because.
All right.
What else might happen?
It
Josh?
expands.
Okay, it expands. I'll get to you, Josh. Expands. Josh?
For the first one, it might contract when the air and the contents inside of it, shrink. It'll,
Okay, so it'll shrink.
the threshold of the can will collapse as well.
Right. That's,
Air inside shrinks. Shall I write that? Does that sound about right? And
well, can contracts, expands. What else can it do? Or could it do?
I just have a question about the beginning. Okay, so at first you put tea inside.
I just put a small amount of just room temperature water into the bottom of the can.
Oh, that's all.
Yep, that's it.
And after that, you close the can and you.
After that, no, the can lid is open.
Yeah.
I'm going to put it on the burner, which I can actually do now, start warming it up. But I just want to make sure if there's any other predictions.
And there is only water?
Just water.
Okay.
Just a little bit cooler water.
yeah, we
think-
just cooled it down with a bit of ice.
We didn't have to, but it just makes more of a dramatic effect. So we have two predictions so far. Any other predictions that might happen to the
I
can?
think it might collapse.
We've got that one. That's number one. It's going to contract.
Contract and
Yep.
tear them like it will be.
I know you just said it would be dramatic, but it could do nothing.
Good.
That sounds good.
That's what I'm saying.
Okay.
Okay, there you go.
Do the same.
Get her on there.
And why do you think that? That nothing will happen to the can itself?
I think a reasonable person might think that because of the metal in it, it just holds up. Strong
metal
enough to
will be
withstand
like-
it. Yeah.
Sturdy enough
Yeah.
to stand up? The metal will hold shape. I forgot who said the second one. And why do you think that would happen? Or
The
why
air
would
will push
a
out.
reasonable person think
A
that?
reasonable person might say the air would try and escape the can and push.
Because the air expands?
Yeah.
Inside. Okay. Are we ready for the experiment?
Pretty close. I can start hearing it bubbling now.
Anybody else with an idea that what a reasonable person might think? What will happen to the water in the actual
Oh.
container? Any ideas about that? Yes,
It'll bubble. It's released.
as in boiling? Or-
Yeah, I guess, yeah.
Okay. And that is because can, like,
Hot.
Yeah. Speaking of hot, any predictions of what happened to my hands if I touch the can?
Sandra, do you have a?
I'm supposed to use, you're supposed to have toggles or whatever.
Was it, no, it was.
Yeah, I just was similar. I was just gonna say that some of the water will evaporate.
Lisa.
Which,
Sorry, I
which,
did it again.
evaporate
That's
here?
okay. Evaporate. Yeah, some of the
Okay.
water will evaporate.
Okay, well, I got a glove, so.
Oh.
I also getting my first 3 burns.
I'll put cash for you.
Yeah.
Okay,
I did this a couple times. One time it didn't work, one time it worked beautifully, so let's see what happens this time.
well, that worked.
Oh, oh.
All right.
Did you notice that? So, now, let's go over the observations.
Mhm.
What did we observe here? What things happen here that you can observe?
The can contracted,
Okay,
it folded in on itself.
cool. Anything else you noticed that happened? Physically, anything else?
The water all went up into the can.
You noticed more water went into the can than I put into it, right?
Right.
Anything else you noticed?
It made noise.
What a noise, eh, didn't it?
Yeah.
Did it do anything else?
It contracted like widthwise instead of lengthwise.
Yeah, but it actually went lengthwise too.
Oh yeah.
It's much shorter. Yeah, went both ways. Anything else you observed? It kind of jumped out of my hands. Put it in there and it just went right down into the water. So that's something else that,
The some of the water being coming outside.
What, what's that, Shane?
Some water is coming out in the table, like there was a bang
Yeah.
and some water also.
Actually, yeah, you're right. Some of the, it just, I guess the force of it pulling down in, it made it splash, so the can itself displaced the water, and wasn't any real chemical reaction or that, but it just came up. So,
What else can we observe about the water that's left?
So can we use this force in making any bomb or any
make it what?
bomb or any?
A bomb?
Opposite effect.
Probably the opposite of a bomb. What's the opposite of a bomb?
Yeah, what's happening here?
Exactly, implosion, okay? So explosion is the force is going where? What direction is explosion?
Outside,
Going outside, like
going
outward.
Outward.
And so what would implosion be? Forces,
Inward.
okay. And what would cause the water to rush up?
Pressure differential
Of what?
of the air in the can.
So how much pressure is in the can at the time that I'm flipping it over and putting it into the surface water?
Well, I think there'd be a lot of pressure in there because of the boiling, or the evaporation in the
So do you think it's high pressure?
gas.
Low pressure.
Or low pressure.
Well,
Temperature.
who thinks high pressure, who thinks low pressure in the can?
I thought high pressure.
So high pressure, anybody else? High pressure?
No.
High pressure? And then high pressure? And then who thinks low pressure in the
I
can?
think low pressure.
So more people low pressure. Okay. And would it do anything differently maybe if I had the can the opposite way? So say I took the can with a hole and say I put it in bottom first. What do you think?
You still have a bit of the can crushing, but not nearly as drastic. I
Do you have another can?
Yeah, I do. Well, we have time for it. But,
There's time, Matt, isn't it?
Yeah, you're at
For one?
9. And we can always take a little bit of time at the end to mess around.
okay.
Okay.
So let me just put a little bit in there and try it.
There's a little bit of music.
Is it?
You're not stealing anyone else's time by taking a little longer today, so it seems like it's worth investigating.
All right. Do you think the time that the implosion occurred was the exact same time as the water entered the can?
What? Yeah.
The time of the implosion, it contracted, was that the exact same time the water went into the can?
No.
Who says yes, who says no? Who says yes, that precisely the same time it happened? So it got crushed and the water rushed up at the same time. 1, 2, 3, and who says different times? Okay. So basically, why would that be? Why would it be different times?
Because evaporation goes up.
Evaporation? Okay,
Yeah,
Chad?
Because at first they come into contact and it takes at least 1 or 2 seconds to make the next step.
Yeah, okay. How about surface tension of the water? May have caused a little bit of a delayed reaction, so
It's also the mass of the water.
mass,
It's actually-
mass
there's
inertia
more
and also surface tension.
Inertia, yeah.
So a little bit of resistance of the water going up because of surface tension.
But it's about a microsecond, so not really observable to the eye.
So you're saying the can collapses first, then the water?
Yeah, scientifically that's what happened. We can't see it, you guys couldn't observe it, but I wanted to bring it up just to point out to you that it actually happens just slightly bit time after the implosion, is the water rush.
I think in the video, if you make slow down, we can found it.
Yeah, possibly, yeah. Boiling happening.
So another interesting thing about boiling water is that the actual temperature of boiling water is about 100 degrees Celsius, but at what level?
Not at the beginning is 65 degree, and when it is 100 degree, that means a lot of bubble is coming up and a huge amount of steam.
It's turning into gas. Yes, into water vapor, yes. But what I actually meant was there's different boiling temperatures depending on the elevation you're at. So we are at 189 meters. So it's
How many
really only
feet?
a tiny fraction.
How many feet's that?
I have no idea.
600 and some odd feet, 600,
Yeah.
yeah, 637.
Less than that, yeah.
Under pressure.
500 something, right?
There is under pressure.
So it would actually boil at 99.5 degrees, turn into water vapor. Yes?
Yeah, I know, like at 3,000 meters and 3 kilometers, I think water boils around 87 or 88 degrees. So I think it messes up, people are really finicky with their tea or coffee.
Yeah.
Kind of,
No problem.
temperature and kind of goes it
Okay,
all.
let's see what happens here, guys.
Okay.
It's going to be upwards.
Stepping back.
Ah,
Ooh.
It's expanded.
nothing. And nothing. So,
Nothing and nothing.
so,
So, what happened here? Any ideas?
Because
Well, like the air could escape
just
out of the galley. There was the air basically rushing.
Not-
instead of
not the
water
air,
rushing
but-
in.
the water
No,
vapor.
he just corrected it.
Yeah.
so.
But one thing I want to say, if it would be transparent, then we would see different scenario. Then we could see how the inside boiling water is getting cooled down and all the thing is happening and nothing is happening to this. If it would be transparent,
okay.
we could see the inside, what is happening in the inside.
Unfortunately, I don't think there's any metals that are
I just have one more,
not opaque.
one more question, guys. Any idea of how many times of pressure change there is between the going from a liquid to a vapor and back to a vapor to a liquid? So what would be
With water.
the atmospheric pressure difference? How many times does water have to contract? Does gas have to contract to go back to its water? How many times? Just roughly.
It's
Take a guesstimate.
10?
Any other guesses?
500,000.
There we go, 600. So that's kind of, did you know that or just a wild guess?
Wild guess, awesome.
Yeah.
600 times. I did not think it would be that much.
600 times what I can understand.
Yeah,
600 times, the gas has to contract.
yeah.
600.
And then it goes the other way too.
And the other way
Gas
as
has to
well.
expand 600
It
times to
expands.
get to its new state. And the two,
Which-
For all
Which
the
means
molecules
we
that
go-
kind of like come together to form like the liquid structure.
Mhm.
So that's what
That's correct. Yeah, it has to get denser. So that's why when we put just a tiny little bit of water in there and boiled it, and it went to its gaseous state, it pushed out all the air, right? So the water vapor pushed out all the air. 600 times.
and what's the process of going from liquid to gas called? Josh? Exactly.
correct.
and the other way around from
Condensation.
gas to water. That's it, guys.
Awesome.